So hey, there's currently an argument going on about the mold effect, where you take a bunch of beads pretty much, or beaded cord, and put it into a cup and drop it. And what happens is that as the wire drops, there's an overshoot pretty much that looks kind of like this, that stays into the air. And there's a debate going on what causes this. And on the one side, you have Mould and some other guys from Stanford that say that it's because of the rigidity of the chain they're using, where it kind of pushes against the surface while leaving the cup and creating some sort of lever that speeds up the wire as it goes out of the cup, and that leads to overshooting. I'd argue this is completely wrong, because you can actually do this experiment with a very, very flexible rope or wire like this. This does not have any potential to create a lever on the bottom of the cup, and it will still create an overshoot. So let's see what happens if I just push this. We can see the effect is there. It's really minimal, but it is there. I would say there's exactly two things that that support this mold effect to happen. One is you need a very smooth wire, so it does not create any sort of friction when it hits the edge of the cup. That's why some of the chains they were trying this with don't really work well. And the other thing that I think is important is the weight of the wire, because as the weight of the wire increases, the downforce increases as well. So does the velocity of the wire falling out of the cup. And if we increase the velocity of the wire, of the side of the wire that is pulling the other half of the wire out of the cup, we create a lot of momentum on the wire that is actually leaving the cup. And this then creates the mold effect. I attached a weight to it to increase the velocity of the wire dropping and to actually increase the mold effect of the wire coming out of the cup. So we should be able to observe the mold effect with this experiment quite well.